Right, so the first one, 13.1.1. In triangle SQP and triangle SMQ, okay, all we need is prove two pairs of corresponding angles. That's all we need. Two pairs. Once we prove that two pairs of corresponding angles are equal, the question becomes a piece of cake. And there is no need to get scared, to have an increase in heartbeat. This should be an indicator that, okay, there's a common angle. Okay, there's a common angle.
Everybody attention, please. Let's start for Cameron and the meeting window. Please could you come to the finance office now? That is Cyprus, Cameron.
Okay, so number one, we have angle S, that's common. Okay, and number two, let the names of the given triangles guide you. Okay, let the names of the triangles guide you. So I've got angle S and angle S. So that's the first part, they are common. Then Q, we have a triangle S, okay, SQM, so we're talking about this SQM, that's the triangle there. And then we have got SMQ, okay, so we've got SMQ, that's the one. Then SQP, that's SQP. Okay, let me try and draw them. But now if I draw, I end up messing up some of the numbers there. Okay, I won't do that. So I'll just leave it like that. So you've got your two triangles, SQP and SMQ, right? Now, SQP, that's SQP is this angle. That's the whole angle here. SQP, that's SQ, there's a P there, that's the angle there. Okay? Then SMQ, that's SMQ, is this angle. Okay? Now, sometimes it may be difficult, like in this case here, to try and prove that this angle here, that is, it's Q what? I think it's Q2 is equal to angle M. It can be challenging. But if you can't do it, then forget about this angle and that angle. Try this one here and that one. In most cases, if you get stuck with the second one, based on the names, go to the third pair. Okay? Quickly go to the third pair and see if you can prove that the third pair are equal. When I say third pair, I'm referring from the name. There's this Q and that M there. So it can be challenging sometimes, not always. So let me try and prove that this angle P and Q are equal. Now, the P is going to be, if you name it, it's going to be SPQ. So it will be SPQ, which will be this whole angle. Okay, let me use a different color. Okay, it will be that whole angle. Then this one here, it will be SQM. SQM, it will be that whole angle. Okay? Now, this pair here, that is those two, it is possible to prove that they are equal. Okay? Both of them, they are equal to one angle. Both of them. So we have a line here which is parallel to TR, that is QM. So this angle and T3 are corresponding. Okay? They are corresponding. And then T3 is an exterior angle of a cyclic quad. So T3 is going to be equal to this whole angle, which is equal to SPQ. Okay, so I'll write it down here. So first thing, I'll say T3 is equal to angle, okay, I'll call it angle SQM, okay, SQM. My reason, corresponding angles. Then, please don't forget to state the lines that are parallel. Don't forget that, to state the lines that are parallel. So, TR is parallel to QM. Okay? That's the first part. Remember, the objective is to prove that the angle here is equal to that one. That's the objective. But I can't do it directly. I have to go via a third angle, which is common to those two. Then, from here, let me go to the next page. Right, because I don't have enough space. But let me try to do it here. I'll just squeeze it here, but it can be on one page. Then, T3 is equal to, now T3 is also equal to this whole angle, which is going to be SPQ. So that's SPQ. And your reason there, exterior angle of cyclic quad. Okay, since we now have this and we have got that, it therefore means that the right hand sides are equal. Therefore, since I've got SQP, I'll start with that one. Therefore, SPQ is equal to SQM. Okay, so I've got two pairs now of corresponding angles. I'm almost done. I'm almost done. Third one, don't have to stress, right? It will be, that will be angle SQP. SQP is equal to SMQ, and that's based on sum of angles in a triangle. Okay, therefore, those two triangles are similar. SQP is similar to triangle SMQ. Okay. Right. When I was marking some of your work, please don't forget to put the reason here, AAA. Okay. Don't forget to put the reason AAA. Okay. And then you're done. That's 6 marks. And these 6 marks here, if I were to be honest with you, if you really know your stuff, these 6 marks they're easy 6 marks. They are easy 6 marks. Yes. A similar triangle. So if you go back, we have got QM, right? The QM, from the name of the triangle, we can get it here. Okay, we can get it here. The QP, we can get it there. Okay, you can see that from the two names of the triangles, you can identify the corresponding. So QP and QM, or you can say PQ, whichever the case, they are corresponding sides. Okay, so we need to determine what their ratio is. That is equal to 3A over 2B. At the same time, we have got this ratio that we are given. 2ST is equal to TQ. So I'm going to add that on the diagram. So 2ST is equal to, because for me to end up having that 3 and that 2, the A and the B, it means I have to consider the length of ST, I also have to consider the length of SR, and I have to consider that ratio. The fact that there is a ratio or ratios given in the question, it means you have to use them. You have to use them. And the only way to use them, proportion theorem or similar triangles. Okay, so from there, let me put that on the diagram. So we have 2st is equal to TQ. Okay, so if I call my TQ 2x, my TS will be x. Okay, and my SR is going to be y, my SM is going to be 2y. Okay, using ratios, right? Using ratios. So let me write now my equations or statements. And I also given ST is equal to A. Okay, now because ST is equal to A, I'm going to change this from X to A. Okay, because ST is given as A. So I can change that. Okay, let me, I want me to allow me, because sometimes it won't allow me to take back my diagram. Okay, it won't allow me. Please allow me to just cancel that and rewrite this as A, and that one will be A. Okay, this one I can call it Y, and that one in fact, I've got B here. I've got B. My SR is equal to B. So let me change this to B, and that one will be 2B. Okay, if you don't want to do that, then you can say let A be equal to X and let Y be equal to B. Okay, but I want to change it on the diagram. Okay, so once I have that, then I can carry on now. So from here, it will just help me to write the ratios because I don't want to continue going back. From similar triangles, what are the ratios? 3 ratios. SQ over QP over MQ, TS over QS. Right. Once you write these 3 ratios, please, there is more than one way of writing the reason. You have to write the reason. Please don't forget to write the reason. Okay, from now on, I'm just gonna use the shortcut. This is in the examination guidelines, or you can just write the names of the triangles there, which is what I've been doing in the past, but you can write that as well. Okay, then from here now, you can see that you have got your QP and your MQ. QP, this is your QM, that's your QP. Okay, RP is equal to PM. Okay, that's given. Okay, which means RP, or say SP, SP will be equal to 2B. Okay, therefore, from here, if I take my QM over QP, that must be equal to, so my QM is that one, equal to QS over PS. Okay, so this QS is equal to 3A. Okay, based on my diagram, and my PS is going to be equal to SR plus RP, which is equal to 2B. Okay, so it's fine now. Right. Okay, so that's it. So the diagram is very important, and also the information that's there is very important. Unfortunately, I missed that part. All right, you're following that? Right, let's move on to the next one. Now, the next one, it is further given that QPT prove that it's a tangent. Right, this one is so simple. Right, if you want to prove that a line is a tangent, there are 3 ways of proving that a line is a tangent. Either you can use the converse of the tan-chord theorem. You can also use the converse of the tan perpendicular to radius, or the tangents from a common point, any of those 3. The most common one is the tan-chord theorem. Okay, the most common one is the tan chord theorem. That's the most common one. So, if we are told that these two triangles are similar, it means their corresponding angles will be what? Will be equal. Okay? So, if you are told that QM is the tangent to circle QPRT, this is QM, that's QPRT. So, all we need to do is, if we can prove that this angle here, that is Q1, it's equal to angle T1, then we are done. Okay? Then we are done. Okay? So, let me bring that diagram. Okay, let me bring the diagram. What are we going to do? Here, the angle that you're supposed to prove that they are equal, okay, is going to be.
Sorry for the interruption. This is going to be mechanism periodically.
Okay, so T1 is equal to Q1 because of similar triangle. Therefore, QM is the tangent because of the converse of the tan chord theorem. Okay, and then you are done. It's 3 marks. So 1 mark will be for the statement, another mark for the reason, the third mark for this reason. Okay, that's how the marks will be allocated. Right? Any question? Then 13.2.2, TP equal to 4B over 3. Okay, TP equal to 4B over 3. Right? TP is that. Now that TP, we have to use the similar triangles. Because this is a ratio, or a length rather, you can use the two triangles that are similar. So with that, we just write the ratios and see what information we got from the previous diagram, then I'll just substitute that. So can you just help me with that? Okay, in fact, I've got it now. So my 13.2.2, it will be QP over MP is equal to PT over PQ. And that's equal to QT over MQ. Okay, using similar triangles. Okay, as I said, here you can write the names of the triangles. Fine. Okay, then from these three ratios, right, we have to choose one which has got PT, which is this one. Okay, that's our TP. Our PQ, we know, okay, PQ, we don't know what the length of PQ is, okay, based on the information, right? And we have got that QP, we know this QP we have got that MP, then we have got QT, we know what QT is, okay, we know what QT is. These two we don't know, okay, but QP we don't know, MP I know that it's equal to B, okay, MP is equal to B, so I've got this, right? This PT is the one that I want. My QT is equal to 2A, so I've got that. Okay? MQ, I don't know what MQ is. Okay? So what that means is I only have this one and that one, which means probably I might need to use my proportion theorem. Okay? How am I going to use my proportion theorem? Was for me to be able to get this Q, let's see. I've got the QP, I don't have it. The MP, I've got it. PT is the one that I want, this one is the same as that. QT, I know I can write that in terms of A. The MQ, right? I've got a ratio which I had in the previous question. This one. You see this? You see that? Since I don't have any other information, the third one means I can use that one to carry on. Okay? So QM over QP is equal to 3A over 2B. Right? So let me just write it down somewhere. It's QM. Okay, let me go to the next page. Let me go to the next page. But QM over QP is equal to what? 3A over 2B. Okay? QM over QP is equal to 3 over 2B. Now, if I go back here, okay? If I go back here, I know this QT, I can put it. This MQ, I can substitute with something else. The PQ, I can write it as well. So I can swap these two. Do you see that? So I'm going to use these two ratios to get my value for what? For PT. So I'm going to move on to the next page and I'll say PT is equal to, it's going to be equal to QT times PQ over MQ. Okay? So that will be PQ times QT over MQ. Okay? But you see these two, I have to swap now. That because I've got PQ on top and MQ at the what? At the bottom. So, and I know that my QT is what? You look at the diagram that I had here. It's 2A. That's QT. So I can write this as 2A. That's for the what? For the QT times the PQ over MQ is going to be equal to 2B over 3A. Like that. Okay? Now, see, when you get stuck with this question, it means probably you are missing something. Just go back and see. Okay, it will help. You can make mistakes, of course, but just go back and see where you are missing something. You probably pick it up. So this becomes that A and that A cancel. So we end up having your 4B over 3. Okay. Now you can see that everything that I did, I used the information that's provided. So when you're doing these higher order questions, every information that you are given, it means somehow you have to use it. You won't get a question which is from nowhere. No. The whole question has got a connection. If you miss one part, you might end up having a problem with the next. All right?